Hello everyone, welcome to Miss Molecular classes. In this video, I am going to continue with the finding the oxidation number of the given complexes. There are two complexes here. The 12th complex is having the what it is bridged ligand here. Let me start with the what it is 11th question here. Finding out the oxidation number for what it is. This mercury is acting as a counter ion here. Cobalt is a central metal ion, and SCN, that is thiocyanate, is acting as a ligand here. So when we dissociate this complex, it has to dissociate as Hg plus ion, and here it is another one is as a negative ion. But in case of Hg, Hg exists in +1 as well as +2 oxidation state. So, but in this complex, it is going to be existing in +2 oxidation state because it is having an atomic number 80 and its electronic configuration is xenon 4f14 5d 10 6s2. So with this configuration, with this electronic configuration, when it loses 2 electrons, the molecule, the Hg atom is going to become what it is stable with a +2 ion. Whereas if there is a loss of only 1 electron, then it is going to be having what it is incompletely filled electronic configuration, henceforth it is going to be unstable here. So that Hg is going to dissociate as +2 here. Let me dissociate that one. The complex is getting dissociated into Hg2 plus and the same charge will be on the what it is another complex here, cobalt SCN as acting as a ligand 4, and it will become 2 minus here. So this complex is dissociating into cation and the anion here. So now finding out the oxidation number of cobalt in this case, let me take it as X here, plus thiocyanate ligand, that is SCN ligand, is having a -1 charge. So it is how many are there? 4 ligands are there. So it is 4 into multiplied by 1, and the charge on the complex is equal to -2. So it is x minus 4, which is equal to -2. X is equal to -2 plus 4. So the oxidation number of cobalt in this case is +2. So the oxidation number of cobalt is +2 in this example. So let me discuss with which one here. Next example. In this example, this OH ligand, which is known as hydroxide ligand, is acting as a bridged ligands here. Because of bridged ligand, we will write the oxidation number, and there are 2 chromium atoms are there. So 1 chromium oxidation state, that will be equal to how much we have to calculate. First let me write this H2O ligand is a neutral ligand. So the charge on H2 will be 0. How many H2 are there? 4 here and another 4 here. It will be 8 H2O ligands, and the charge on these ligands will be equal to 0. Whereas we are having another bridged ligands here, 2 OH ligands are there, and that charge will be -1 will be, that is negatively charged ligands are present. Now let us calculate the what is oxidation state of chromium in this case, and the complex charge is what it is cationic charge with a +4 as the charge here. So let us consider. Here I'll take this chromium as there are 2 chromium atom. Let me take it as 2x here, plus how many water ligands are there? Aqua ligands. There are 8 H2O ligands are there. So it is 8 into 0, plus there are 2 OH ligands are there. So it is 2 into the charge on OH is how much here? -1. So it will become -1, which is equal to the charge on the whole complex is equal to what it is? +4 here. Now 2x, this is 0, -2, which is equal to +4 here. So it is 2x is equal to 4 plus 2. X is equal to, it is 6 upon this 2 will shift here. 2 1s are 2 3s are. So x is equal to +3. Each chromium in this complex, each one of the chromium is going to have oxidation state as +3 in this examples.